Dear students, good evening to you. It is 15th February 2025 and time is about 5:35 p.m. evening time. I'm really happy to see you and welcome you both in this class again. And as you know, I am Dr. Dinesh Kumar, Principal Scientist from Division of Agronomy, ICAR, Indian Agricultural Research Institute. If you recall that two important topics have been covered by us in some lectures. These topics included principles of crop production. We discussed in length, at least in two lectures, I think. Then we started factors affecting crop production. They have been completed in almost 3 lectures or say more lectures. And now fresh topic starts. You do not bother about part 1, lecture 3. You don't bother about it. Just you see the title or the topic of the lecture. So we are going to start law of variable proportions or diminishing return in crop production. What is meant by this law? What are different stages of this law? All these issues we will discuss. But in today's lecture, I would like to discuss some terminology or glossary and certain important topics related to this law. So today we are not going to explain or understand this law actually, but we will see the associated topics to this law. But before that, I just want to tell you that law of variable proportion and law of diminishing return are almost synonymous. But if you want to make a distinction, if you want to make a difference in these two laws, then we can make. Law of diminishing return is the third phase, is the only third phase of the law of variable proportion. In law of variable proportion, you will have all the 3 phases of the law of the diminishing return. For example, first it will be increasing return, then decreasing return, and then negative return. There are 3 phases in the law of variable proportion. In stage 1, increasing return, stage 2, decreasing return, and stage 3, negative returns or diminishing return. So it is only stage 3 which covers the law of diminishing return. Stage 3 covers the law of diminishing return. However, law of variable proportion covers all the 3 stages. For the time being, you just remember this because the production process has to pass stage 1 and 2 so as to reach the stage 3. Stage 3, that is diminishing return, cannot come directly. First, it has to pass through increasing return, then decreasing return, and followed by negative return or diminishing return. So only the third phase is diminishing return, but law of variable proportion covers or includes all the 3 stages. This is very minor difference. Otherwise, there is hardly any difference in these 2 laws. Now, today we will discuss the meaning and types of resources, what is meant by resources in economics, and then we will describe various production functions, short and long-term time, what is meant by short-term, long-term, fixed and variable factors in crop production. We'll see the meaning of all these, and then we will see different kind of productivity measures, how productivity can be measured under agricultural economics or in the field of crop production. So productivity can be measured by average product, total product, marginal product, partial factor productivity, and total productivity. Besides this, we will also see elasticity of production as a productivity measure. Now, agribusiness means agricultural business. So agriculture operated by business and involving all activities in the business of agricultural production. That is agribusiness. Agricultural productivity is a measure of the economic productivity of a given quantity of agricultural land, typically expressed as the ratio of agricultural output to the agricultural input. Mostly it is a ratio of output to input. That is productivity. But output you can define only one, you can define only two. Similarly, input you can define one, you can say input two, input three, input four. You can take individual input once a time, or you can take many inputs and see the combined productivity. I'll discuss in detail that makes your partial factor productivity and total factor productivity. Factor is your input, output is your product. So sometimes you can combine all the factors and divide output by all these factors. Then that becomes your agricultural productivity. Enterprise, an identifiable sector of the farm or horticultural business for which output includes valuation of unsold stocks produced by the enterprise. This is typical definition of an enterprise. Fixed cost, cost which do not vary with small changes in the scale of the individual enterprise. For example, machinery building. That is your fixed cost. Means once you have purchased a machine, whether you are doing cultivation in 1 hectare or half hectare, whatever, the money spent on machinery is already made. So it does not vary much with the scale of production. It is almost fixed. And many times fixed costs will occur even you do not produce anything. You have not sown the crop, you have not used the machinery. So whatever money you have spent on building or on machinery will be considered, will be spent, whether you produce, make production or not. But these costs are always there. Now inputs, as I tell you many times, inputs are factors, or you can call them resources also. So resources used in the production process, for example, feed for animals, materials, labor, and machinery measured in physical or financial terms. So inputs can be measured in physical or financial terms. Physical means you have seed rate, but if you convert the seed rate into money value, then that will be in financial terms. Produce is your output, yes. Any doubt?
No, sir.
Okay. So produce is actually output. A variety of farm-produced food crops, including fruits and vegetables, and sometimes also grains and other products. So definitely produce will vary with the kind of enterprise we have. If it is poultry, then meat or egg will be the produce. If it is vegetable, the vegetable part or economic part of the vegetable will be produced. So you know whatever has been produced directly by consuming or by using resources or input, that is your produce. Production function. It is a quantitative perception or quantitative relationship between input and output. Quantitative relationship means in numbers. If I use 3 number of labor, what is my output? What is my output? So that is relation of input and output in terms of a function, in terms of an equation is called as production function. The inputs are various factors of production like land, labor, capital, and enterprise or entrepreneurship, whereas the outputs are the goods and services. So many times services are also considered as your product or output. Total factor productivity and also partial factor productivity. So today I will explain it in detail. So there is no need to discuss it here. Okay, now coming to variable cost. Cost which vary in approximately direct proportion to the scale of enterprise. For example, fertilizer, pesticide, and seed. These are our variable costs, means which changes with the level of production. These variable cost changes with the level of production. If you produce less, for example, by using urea or any fertilizer, if you want to produce more, you can increase the dose of fertilizer. up to some extent, you can increase the production by using variable cost. And they vary with the level of production. So now you will see cost in detail. So costs are also classified at direct and indirect costs. So one, you have seen fixed cost and variable cost. Fixed cost, mostly machines, buildings, and variable cost, mostly your seed, fertilizer, or other kind of inputs. They are variable cost. So they are divided as direct and indirect. So direct costs are actually expenses directly associated with production of specific crops, livestock, or agricultural activity. For any enterprise, you are using certain direct expenses. They are your direct cost. For example, seed, fertilizer, pesticide, herbicide, animal feed, veterinary services, planting, transplanting, all these, the money spent on these are coming under direct cost. Now you see what is indirect cost. Expenses that cannot be directly attributed to a specific crop or livestock. You do not use directly on them. But such expenses are necessary for overall agricultural operations or agricultural activities. For example, utilities. Utilities are indirect costs that are always there. For example, electricity on the farm. You may use sometimes electricity. You may use water, drinking water, fuel used, maintenance and repairs there, depreciation value, administrative expenses. Suppose you have some office expenses, accounting services or legal fees, etc., and insurance, etc. So these are your indirect costs. Now, coming to inputs or resources, I have already discussed in principles of crop production, but here just to refresh your memories, you can see it. Resources used for production of a product are factors of production, also called inputs. Use of the services of land, labor, capital, and management or organization in production. These are all resources. Output is the commodity produced by the inputs. Now, see land. It is not just soil, not just landforms associated with Earth's crust. It is not mountain or just valleys or just flat land. It includes your resources like minerals, forest, groundwater, all given by nature. Any resources given by nature are part of the land, even your air in atmosphere. And there may be two kinds of resources. One is renewable, like your forest, or you can say sunlight. Sunlight is renewable resource. And some are non-renewable resources, like minerals, petroleum product. Once consumed, they are gone forever. An example of a key land input in farming activities is a productive topsoil. So productive topsoil is part of land, like we have light, like we have forest or minerals. Now, next resource is labor. You know, in any production, nothing can be produced without labor. So all labor services used in production with the exception of managerial activities. So managerial activities will be part of the organization or management or entrepreneurship. In crop production, labor activities include seed bed preparation, planting, irrigation, chemical application, harvesting, etc. Means your cultural practices or production practices are accomplished with the help of the labor. Capital. So capital have got different meanings in different contexts. So capital in production, what is capital? In production, capital is manufactured good. Sometimes manufactured goods are also used during the production process. So capital is actually used in the production process. So like fuel, chemicals, tractor, trucks, and building that provide productive service to users. Capital goods do not provide consumer satisfaction directly. If you are using tractor, consumer is not bothered which machine you have used or which seed you have used, or which irrigation you have used. It is none of the business of the consumer. So consumer will not feel the value of the capital. So it can be divided into two. Capital means consumable capital and durable capital, means items which are consumed during the production process are your capital. For example, seed, fertilizer, chemicals, water, they are consumed during the production process. So they are consumable or short-term capital. Long-term capitals are your machines, tractor, or buildings, houses, roads, etc. They are indirectly helping the process of production. Is it clear? This capital? Capital is not money, but money is used to buy these resources. Money is used to buy these resources, and some resources are immediately consumed, and some are consumed again and again, year after year. So year after year is your long-term capital items, and short-term capital items are your seed, fertilizer, which are directly consumed in the production process. So, okay, it is there. Non-durable capital inputs like consumables, fuel, chemicals are entirely used up during the current production. And durable capital inputs, machinery and buildings are utilized over a period of years. Now, the fourth and last one is the farmer, the grower, or the manager, or the organizer, or entrepreneur. So, a lot of decisions are made by entrepreneur or the farmer. So, main role is decision making. Its functions are varied and easier to conceptualize than to measure. Like farmers must make variety of decisions, how, when, and what to produce. What kind of crops should I select? It is his duty, it is job. How best to organize the inputs, means first thing is how to arrange the input, what quantity of inputs should be arranged, and what is priority in buying the inputs. All such decisions are made by this entrepreneur. When and how to market the output. When your production has happened, will he like to store it for a long time? Will he like to sell it immediately? Or part of it should be sold, or how much may not be sold, like this. You can write down 1,000 decisions. More than 1,000 decisions are made by farmer day to day. You see, day to day, number of decisions are made. Suppose today is rainfall. He has to make the decision, or today he is expecting rainfall. Then farmers need to make decision. Can I go for irrigation or not? Can I go for foliar spray or not? Depending upon weather conditions and depending upon the time of the crop. You see, every day farmer takes number of decisions. Should I control my weeds today? Should I control my weeds tomorrow? Should I use chemical? Should I use my cultural practices, or what? Means you can believe, just think that every day farmer has to make decision about the crop production. And not just during the crop production, before crop production. When to do sowing of the crop, how to do it, how to arrange the seed, how much seed I need, how much fertilizer I need. So these are actually all decisions from day one to disposing or selling his product. So you can understand. I need not to explain. More than 1,000 decisions, or maybe more than 10,000 decisions are made by a farmer or grower. So how to arrange finance, how to expand production. So all these decisions are made by the farmer. Now, production in economics. I have already exposed you to the topic principles, crop, and production. Production, I told you, conversion or transformation of input into output. Just a quick look. So farm means your farmer, maybe a farm here, buys inputs, and inputs are actually productive resources. They will produce. And outputs are what it sells. What we buy is your input. What we sell is your output. Simple. This is another perception of defining input and output. And quite interesting. What a farmer buys is generally input. What he sells is your output. It is not creation of matter, but creation of value. Production is creation of value. producing goods which satisfy some human want. Means this is one more definition of production, producing goods which satisfy some human want or human needs. That is also production. One view of production. Another may be technical processes requiring the mental, physical skill of craftsmen and consist of changing the shape, size, and properties of materials and converting them into useful article. So this is some comprehensive definition of production. Now we directly come to the production function. Production function can be written as PF, the production function. So now seek your attention, critical attention. A functional relationship between quantities of input and output. Production function means it is simply an equation, or it is simply a relationship between input and output. So if I use so much of input, so many inputs, what would be my output? So this is in quantitative terms. In physical and quantitative terms, we have production functions. So it shows how and to what extent output changes with variation in input during a specified period of time. If I am using 100 kg fertilizer, how much is my production? If I use 50 kg more, how much will be change in my production? So this kind of relationship can be expressed in mathematical form, in relationship form of input and output. So that is your production function. So it can be expressed in the table form. In tabular form, we can express, I will show you. It can be expressed in graphical form and equation form. I think both of you must be knowing that if you have one equation, any equation, and that can be plotted on a graph paper easily. Because in equation, you will get X and Y values. You will get some coordinate, some corresponding value of if X is 1, what will be Y? If X is 3, what will be Y? So from this equation, we can get the coordinates. X1, Y1, X2, Y2, X3, Y3 likewise. And then we can plot it. We can put it on a graph paper. So any equation can be converted into graphical form, into line form. So that is why it means you can show the equation graphically also. So that can show the amount of output obtained from various combination of inputs used in production. So actually in production economics, you call it broadly, you call it production economics. And one small part of production economics is production function. So it is input-output relationship. But in this case, we will also see input-input relationship. Input-input relationship to output. Expressed here. Now see, algebraically or mathematically, it may be expressed as an equation. Q. Q is a function of L for labor, M for management, N for natural resources. Natural resources, many times we do not count them in monetary value, like your light. Who is buying light? Who is purchasing light? But you know, without light, we cannot produce anything. Without air, who is paying oxygen? Who is paying money for oxygen from atmosphere? I think today nobody is paying, but tomorrow I don't know what will happen. But today we get light and air free. And K is your capital, as the name suggests. K is for capital. They didn't put C, they put K, maybe some Greek letter or something like that. K is for capital, and T is for given technology. Now you see, technology has also become one more factor, because technology can change Q. So you can see overall, you see one more addition is there, which is T. So L, M, N, K, T is Q. Now see short run and long run. In economics, you will come across that in short run, demand does not change, but supply changes. In long run, both can be changed like this. So you might be listening in economics, the two words, short run and long run. So let us try to understand what is meant by short run. Is it 2 years period is short run, or 50 years period is long run? For example, in agronomy, we say long-term experiment. So what kind of experiment, or what is the number of year, minimum number of year, then we can call it long-term experiment. What do you think, Palash and Kajal? We say long-term experiment, long-term field experiment. So is it 2 years? Is it 4 years? Is it 20 years? So what is that? Normally, minimum, I think minimum has to be 5 years. 5 years plus. Then we can consider it as long-term. So, but here there is no fixed time. The period, long-term or short-term, will vary according to the enterprise. What enterprise we are having, or what is the nature of the produce, that will decide the short and long run. Let us see. So, functional relationship between change in output due to change in input, that is production function. The first line says it is production function, or production happens, and these relationships are studied under two phases. One is short run and other is long run, time periods. Short run is a period in which output can be changed by changing only variable factors. So in short run, you can increase or decrease the output or the production by changing only the variable factor. Then it is called as short term. So in short term, fixed inputs like machinery, building, etc. cannot be changed because they are expensive also. They are expensive also, costly also. So in general, means if you make changes only in variable factor, so that period is called as short term. Production can be raised. Second case is production can be raised by increasing variable factors, but still the extent of capacity of fixed factor. Because there is limit for the fixed factor also. How many variable factors they can accommodate? How many variable factors they can accommodate? It does not mean that fixed factor will always support all levels of variable factor. It is not. They also got their carrying capacity or bearing capacity. So in this case, production can be raised by increasing variable factor, but till the extent of capacity of fixed factor. Suppose you have just, I give you another example. You have 5 cows, and they may be considered as fixed factor because they live for many years, isn't it? They live for long term. And if you give them feed, say for 1 cow, you get 10 kg grain per day, and you want to increase the milk production, then you cannot give her 20 kg because she cannot eat 20 kg. So you can give her 2 kg more, but there is some limit. You cannot continue to give a dose of the variable factor because fixed factor will not accept it. So similarly, it can be true for other factors also, variable factor and fixed factor. For example, your land, your soil. Soil is definitely a fixed factor. Soil is fixed factor. The value of the land is fixed. And then similarly, you cannot go on adding extra seed rate. Extra seed rate you cannot add. It can bear up to certain extent the seed rate. You cannot give so many plowings. Plowings also have some limit. So you cannot increase production just by, there is some capacity. There is some capacity of the fixed factor too. So there has to be some ideal ratio. There has to be some ideal ratio. Now, let us see long run, a period that is long enough for the farm to adjust all its inputs according to the change in the conditions. Now, thing comes, if a farmer wants to increase milk production, then he should buy more cows. He should buy more cows instead of feeding 1 cow more and more grains or more and more feed. So in long run, farmer can purchase more cows And then he can also purchase more variable factor. More feed he can purchase and he can increase the milk production. But that is possible only in the long run. Because in short run, farmer may not be having enough money. So he can get his money accumulated or collected in several years. And जोड़ने के बाद, after accumulating some money, and then he or she can purchase long-term inputs. So long run is a period that is long enough for the farm to adjust all its inputs, whether it is variable or whether it is fixed, according to change in the conditions. In the long run, farm can change its factory size or similarly cow number, switch to new techniques of production, new setup, purchase new machinery, make houses or make roads, or purchase more land, etc., etc., or establish a new plant. Here, plant means factory. Plant doesn't mean your vegetation. Now, the distinction between short and long run does not refer to the calendar period and not based on a fixed time span. Okay, there is no any fixed time span, like I told you, long-term experiment, it is 5 years. But here, there is no any limit. It depends on production conditions and varies from farm to farm or industry to industry. It depends upon nature of product you are going to produce and kind of inputs you are going to use. For example, 10 years may be short run period for a steel industry. 10 years may be a short run for a steel industry, while a period of 1 year may be a long run period for a wheat producer for farmer, because he cannot wait. Suppose this year he has used 20 kg fertilizer, so he can increase it to 30 kg next year. So, but this 1 year may be a shorter period, maybe longer period for him, maybe a longer period for him. Now see more clarification, short run, long run, meaning in short run, output can be changed by changing only variable factors. Means output can be decreased or increased by changing only variable factor. In long run, both factors can be changed, whether it is variable factors or fixed factor. All factors can be changed. So such a period when a farmer is able to change all his factors will be called as long run. And when he is able to change only variable factor, that period will be your short run. So factors classified as variable and fixed factor in short run. But in long run, all factors are variable in the long run because he can change variable as well as fixed factor. Therefore, in this, all factors are variable in long run. Price determination. Demand is more active in price determination as supply cannot be increased. Here, supply cannot be increased, but demand may increase immediately with increase in demand. Farmer cannot increase production in one night or one day. In long run, both demand and supply play critical or equal role in price determination as both can be increased. So depending upon the demand, in future, you can make supply. So now we can go to link number 2, and I can stop share. I can stop recording. Stop record. So, dear students, let us see the factors, fixed factors and variable factor. What is meant by fixed factor and variable factor? You can call them fixed input or fixed resources, or variable resources, variable input. Variable factors, these can be changed in the short run. Just now opposite what you have seen in long run. You have taken help of variable factor to define long and short run. Now we are taking help of long and short run to define variable and fixed. So variable factors means these can be changed in short run. For example, raw material, casual labor, and power, fuel. Fixed factor, these cannot be changed in short run. For example, plant and machinery, building, and your, of course, your cow. Now, the quantity of fixed factor remains same in the short run. It remains same in the short run, irrespective of level of output. they do not change. Means fixed factor do not change. Whether the level of output rises, falls, or becomes zero. Means suppose if you have 1 hectare land, and if you consider it as a fixed resource or fixed factor, you have grown the crop. Whether you achieve the yield 10 ton per hectare, whether you achieve the yield 2 ton per hectare, whether your crop has been killed by storm, then you get 0 tons per hectare yield. Whatever yield you get, any yield, but you are bound to use fixed factors. Fixed factors are always used, and you can see it does not matter to them whether you get 0 output or more out or less out. Now see the difference in variable and fixed factors. So factors that can be changed in short run are variable factor. Factors that cannot be changed in short run are fixed factors. The variable factors vary directly with output. Generally, they vary directly with output. Up to some extent, you can increase output by increasing the variable factor. But here, it is not the case. They do not vary directly with the output. Example are raw material, casual labor, power for variable, for fixed factor, building, plant and machinery, permanent staff, etc. Now we go to the productivity measure. So actually, it is not soil productivity or crop productivity in that sense. It is overall agricultural productivity. This is with respect to agricultural productivity. So there are number of productivity measures, and this is with respect to economics, agricultural economics. Now we are not discussing typical agronomic productivity, that is yield in tons per hectare or other units. So productivity is an average measure of the efficiency of production. Efficiency of production means simply output by input, simply output by input. That is efficiency also. It can be expressed as ratio of output to inputs used in crop production, output per unit of input. So you can call it efficiency, you can call it productivity. Now, concept of product, you can see concept of product and productivity measures. First, product or output refers to the volume of goods produced by a farm or an industry during a specified period of time. That is called as, means volume of good is your product or output. Different products and productivity measures are. So total product, this is also a kind of measurement. Average product, marginal product, elasticity of production, partial factor productivity, and total factor productivity. So these are actually different measures for measuring the product and productivity. Now you see total product, you know. What is total product? Total quantity of goods produced by a farm during a given period of time with given number of inputs. That is your total quantity or total product. For example, 10 laborers produce 60 kg of rice. Then total product is 60 kg. Is it okay? Total product is 60 kg. This is in relation to variable input or inputs. In short run, a firm can expand total production by increasing only variable factors. Already told several times. However, in long run, total product can be raised or changed, increased by increasing both fixed and variable factors. Total product is also known as total physical product. In economics, where we study input-output relationship, we keep it always in physical terms, in measure term, not in economic terms. Total physical product or total return. This is in terms of physical product. Yield per hectare means mustard seed kg per hectare. This is not money. This is in physical term. So total return in physical term or total output in physical term, not in monetary term or not in money term. It is always in physical term. So therefore, in many times you will find total physical product. Instead of total product, you will find TPP. Average product, output per unit of variable input. Output per unit of variable input is your average product. obtained when total output is divided by the total input. This is your average product. Average product is equal to total product divided by unit of variable factor. So here you are taking only one factor at a time for average product. So this is your average product. For example, if total product is 60 kg rice produced by 10 laborers, that is variable input, the average product is 60 by 10, 6 kg per labor, 6 kg per labor. Here other factors are considered as constant. Other factors are considered as constant. This is not whole economics. This is very partial economics. Total product in terms of average product. Now we can find the relationship between total product and average product. So here it is simple. Total product is equal to average product into units of variable factor. So average product is also known as average physical product or average return. Now, properties of average product. When production function is linear means the rate of change is same. Due to unit change in X, the change in Y is same from one unit to another unit to next unit to next unit. Then it is a linear function. So when you have production function as linear, AP of input is constant. It does not change. AP decreases continuously if production function represent diminishing return. I told you there are three phases: increasing return, decreasing return, and diminishing return. Diminishing means when you get negative returns. So AP decreases continuously if production function represent diminishing returns. When production function shows increasing return, throughout AP increases continuously. For a production function which include both increasing and decreasing return, AP will first increase, then reach a maximum and start decreasing. Marginal product, like you have average product, total product, you have marginal product. Marginal product is the rate of change in total output as related to change in input. Means if I make a unit change in input, how many units change is there in output? That is called as marginal product. So MP in change is change in output or change in total output divided by change in input. So delta Y upon delta X. It refers to addition to total product when one or more unit of variable factor is employed. You increase one more unit of variable factor, then how much is the change in Y? That change is your marginal product. Now, marginal product, you can see MPN, TPN minus TPN minus 1. Because here you will have pairs of the data. At one input level, you will have some output. At input level 2, some output 3 means likewise. So similarly, you can have different pairs. So MPN, N means number, is equal to TPN minus TPN minus 1. So MPN is, or simply MPN is marginal product of the nth unit of the variable factor. Suppose it is 9th unit or 9th labor factor. TPN is total product of 9 units of variable factor. How much is produced by total 9 labors? And TPN minus 1 means total product of n minus 1 unit of variable factor, where n is number of units of variable factor. N minus 1 means जो पहले वाला labor है उसका minus कर. So this is your marginal product. Means if you make x1, x2, x3, and then on y-axis you have y1, y2, y3 like this. So suppose you can do x3 minus x2. Here x3 minus means the y value of x3 minus y value of x2. That makes your TPN minus 1. Simply this is, suppose TPN is unit number 8. So TPN minus 1 is unit number 7. It is like this. So for example, if 10 laborers make 60 kg of rice and 11 laborers make 67 kg of rice, the MP of 11th labor will be MP11. This is number, which number of MP we are talking, for which unit we are calculating MP. So 11th unit of variable factor or labor is equal to TP of 11, total product of 11 minus TPN minus 1, which is 10th unit. So TP is your 67 minus 67. So you can understand, it is very simple. Marginal product is also known as marginal physical product or marginal return. Now, one more way to calculate MP. There are different ways. I'm not making complicated, but giving you one more perception of the thing, of this thing. So suppose MP is changed in TP when one more unit of variable factor is employed. Okay. When change in variable factor is more than 1 unit, the MP can be calculated as change in total product divided by change in units of variable factor. That is means delta TP upon delta N. Suppose 2 laborers produce 60 units and 5 laborers produce 90 units. Then MP will be. It can be calculated. MP is equal to TP of 5 laborers minus TP of 2 laborers divided by 5 laborers minus 2 laborers. Or MP is equal to 90 minus 60 and divided by 5 minus 2. 30 by 3, so it comes out to be 10 units. TP is summation of MP. Otherwise, for every additional unit, we can work out MP and make the total, and that will be MP. That will be TP, sorry, that will be TP. So TPN is equal to MP1, MP2, MP3. If you add all these MPs, then it will become TP also. If you add MP of all the units, it becomes your TP. See, the last TP is equal to summation of all MPs. Marginal product properties. As long as MP is increasing, the TP increasing at an increasing rate. TP continues to increase when MP decreases, but it is greater than 0. It will continue to, TP will continue to increase when MP decreases. In stage 2, it happens, but is more than 0. TP reaches a maximum as the MP becomes 0 and then decreases as the MP becomes negative. So this is start of the stage 3 or end of the stage 2 where your TP is maximum, MP is 0. And in the third phase, which is law of diminishing return. See, in the first case, it was, you see, the TP was increasing at increasing rate. In the second phase, it was increasing, but at decreasing rate. But in third phase, it is decreasing. So therefore, the third phase is called as law of diminishing return. Because actually in the third phase, it is, but third phase to occur, the production has to pass from stage 1 and 2 also. But in law of diminishing return, we should study only stage 3. But in law of variable proportion, we study all the 3 stages. I will explain you further when it comes again. Now you see example to understand TPMP. I will be quick. So inputs, you know, suppose any input 0, 1, 2, 3, 4, 5. Output, it is randomly written. I just took this example from somewhere. And then marginal product. So this output minus this output, previous one, 103 minus 0, so it will be 0. I'm sorry. For the first, for 0, there cannot be any marginal input. I'm sorry. So here, there cannot be any marginal input because before 0, there is no unit. Before 0, there is no unit. So you cannot have a marginal product for 0 input. Okay. But for one input, for input 1 means one level of variable factor, we can have marginal product because this minus this, 103 minus 0, we get 103. Similarly for unit 2, so unit 2 minus unit 1, TP or output. So 174 minus 103, you get 71. 223 minus 174, you get 49. 257 minus 223, you get 34. 281 minus 257, you get 24. It's easy. Now average product. This column divided by column number 1. Marginal product divided by input, you get average product. Okay. And if you multiply average product by input, you can get output. You remember? If you multiply AP with your inputs, respective input level, you can get TP, total product or output. Here TP is your output. Now next is elasticity of production. The EP, elasticity of production, refers to the, you can remember definition of EP, elasticity of production. It refers to the percentage change in output as compared to the percentage change in input. In last cases, we were seeing the absolute values of the input or variable factor. Here we are seeing the percentage. So percentage change, if you make 1% change in input, how many percentages change is there in output? This is called as elasticity of production. EP refers to the percentage change in output as compared to the percentage change in input. For example, if elasticity of production is 1, then it indicates constant return. It will indicate us constant return. Return means 1% increase in input is always accompanied by 1% increase in output. In case of elasticity, when it is 1. Now, if a production function with an elasticity of more than 1, EP, means throughout indicates increasing return. That means 1% increase in input is always accompanied by more than 1% increase in output. Because it is in physical terms, physical relationship. So in this case also, it is possible to know how much percentage change is there in Y due to percentage change in X. A production function with an EP of less than 1 throughout indicates the decreasing return. That is, 1% increase in input is always accompanied by less than 1% increase in output. So you have 3 kinds of elasticity. In one, you are in benefit. In other case, no benefit, neither benefit nor loss. In the third case, farmer is in loss. Now, partial and total factor productivity. So partial factor productivity and total factor productivity. So productivity measure that uses one or more input factors, but not all factors are called as partial factor productivity. So what happens in the production process? In the production process, you can use n number of factors. N number of resources are used in the production process. You can use water, you can use herbicide, you use pesticide, you use seed, you can use labor, you can use machinery. Number of variables are used in the production process, isn't it? Number of inputs are used. So actually the units of all these inputs are not same. The units of all these inputs are not same. If it is labor, we use them in count. Today I have used 1 labor, 2 labor, 3 labor. And we give them some money, some wages are given to the labor. 500 per day, 600 per day, etc. So the units for labor are different. Similarly, if I use seed, I want to see relationship between seed and output. I can use 5 kg, I can use 10 kg, 20 kg, any seed I can use. So I want to see relation of seed with yield or output. Okay, I can see it because the unit of seed is same. But if I want to calculate if I want to keep all the inputs together, then it is not possible. Because if I apply water is in hectare centimeter, hectare millimeter, water is in this unit. If I use machine, it is in hours per hour. Machine ka charge 500 रुपए घंटा ट्रैक्टर का लगता है, 1000 रुपए घंटा लगता है. So the units are not similar. So we cannot calculate, we cannot combine the productivity of 2 or more inputs. So in this case, we need to take only one input at a time. Only one input at a time. And the productivity which is calculated by using only one input at a time is called as partial factor productivity. Is called as partial factor. Means productivity where we take only one factor at a time or one input at a time, that is your partial factor productivity. Now people have made some alterations in this also. For example, I can calculate partial factor productivity of nitrogen by simply dividing the yield by fertilizer rate. I can calculate partial factor productivity of phosphorus by dividing yield by rate of phosphorus application. It can be calculated. You have suppose 30 kg phosphorus, 50 kg phosphorus, 100 kg phosphorus as your input. So you will get respective in output also. what was yield at 30 kg, what was yield at 50 kg or 80 kg. Then divide that yield by level of fertilizer or rate of fertilizer. So you will get partial factor productivity of fertilizer for 3 different rates, for 3 different levels of input. That will be called as partial factor productivity for phosphorus, for nitrogen. But some people now, they have developed the technique to calculate phosphorus partial factor productivity of NPK together, nitrogen, phosphorus, potash together, or nitrogen and phosphorus together. Okay, that is possible because their units are similar and their properties are also similar. So likewise means these days you can calculate partial factor productivity of fertilizers. Similarly, partial factor productivity of herbicide use, you can use 10 gram, 20 gram, 30 gram, and you can see how much is the change in the yield output. So then also, but you need to calculate it differently because effect of herbicide is different from effect of fertilizer. So therefore, this is called as partial factor productivity. But what happens when we want to calculate the total factor productivity? Means whatever factors, fixed factors or variable factors we have used in the production, if we want to calculate the combined productivity of all inputs, then it is possible. But we need to convert it in terms of money. Suppose I have used 30 kg phosphorus, I will know the value of phosphorus. Whatever irrigation I have used, I will convert it in terms of money. So we can calculate the cost of production. You know, common cost of production can be calculated. And then cost of inputs. We can work out how much is the cost of all inputs. And then we know the value of the output and we can simply divide. That will be the total factor productivity. When you consider the investment made on all inputs and convert it into money terms, how much is the price or cost of all these inputs, and at the level of all these inputs, how much output I achieve. So then I can sell it in the market, this output. There may be some rate, some selling price of this output. So I can multiply selling price with the output that I achieved. Then मुझे पता लग गया कि मेरे पास 5 कुंटल गेहूं पैदा हुआ and 1 कुंटल गेहूं का दाम suppose 2200 है, 2200 rupees. I can know what will be value of my output, and then I also know how much was the cost of production, how much money I have spent on this. Then output in terms of money and input in terms of money. That will be your total factor productivity. Or keep the total factor productivity without money. Keep it as such. So 1 kg grain, how much money was used to produce 1 kg grain? As you can keep just the 1000 kg, 5000 kg suppose is the yield, and divide by 50,000 rupees. Suppose 50,000 rupees was the cost of cultivation. So we can know how much money we got it by spending this money. So this is how I think when you work out the economics cost of cultivation, you will learn it. What is total factor productivity? Any doubt? Any doubt about partial factor productivity and total factor productivity? Palash?
No, sir.
Okay.
No, sir.
Okay, fine. Do you have any
Yes,
economics book, agricultural economics book, or farm management book? Okay.
No, sir.
If not,
there is one book in library.
okay. If you do not have, talk to your seniors, talk to your teachers immediately and arrange that book. These days, it is easy to buy it through Amazon or this and that, whatever source possible. You should have one book of agricultural economics. You should have one book on water management, on dryland agriculture, on rainfed agriculture. You should have one book on manure and fertilizer. You should have one book on soil science, one book on seed technology, one book on genetics, plant breeding. Of course, I know you are in agronomy, but agronomy is not just agronomy, my dear. You need to learn agricultural extension also. Maybe in BSc you must be having, but even during your degree time, entomology book, pathology book, you should have. So, for example, you try, but if you have any problem, you want a book in any field, you just write to me. I'll try. Okay, otherwise you try to arrange books, you keep hard copy of the books in your room. ठीक है, खर्चा कम करो, एक पेंट कम खरीद लेना, लेकिन बुक जरूर खरीद लेना. ठीक है. Okay. I used to do like this. I won't buy my clothes because my hands were tied. My father was a very ordinary farmer, so not enough money. But I would buy books. Books was my priority. I don't know about your financial status, but anyways, whatever is there, you should try to buy books. Okay. So we continue. I want to finish it. 10 minutes are left. Partial factor productivity, the average productivity of a single factor measured by grain output divided by the quantity of the factor applied. That is your partial factor productivity. PFP can be measured for any factor of production such as fertilizer, labor, water, pesticide, machinery with the units of measurement depending on the factor. What are the units of measurement? But it can be calculated separately for each factor. For example, I am showing you how to calculate partial factor productivity for nitrogen. So suppose this is the rate of application, different rates of application, 0, 50, 100, 150, 200. And this is grain yield of rice. I put it in kg per hectare. So it is very easy. Divide this column by this column. So for 3000, you cannot divide by 0 because you will get infinite. So you cannot, on 0, you have not used any fertilizer also. So you cannot calculate partial factor productivity here. But 4400 divided by 50, you get 88 kg. Similarly, 4700 divided by 100, you get 47. 4900 divided by 150, you get 32. 5000 divided by 200, you get 25. So these are partial factor productivities at different levels of nitrogen. You can see here, as you increase the doses, the value of PFP is decreasing. The value of PFP is decreasing. And we do not know at what value we will be able to get the maximum return. So here we need to do cost-benefit analysis. This is not the part of today's lecture. At some other day, I'll teach you cost-benefit analysis. But here simply you are seeing if you increase the level of fertilizer, the partial factor productivity is declining. But it is not that 25 kg may not be beneficial. We are not sure. We need to work out the economics. What is the price of 200 kg nitrogen? What is the cost of the 200 kg nitrogen? How much is the price of 25 kg grain, which we have bought due to 200 kg nitrogen? Then economics can be worked out. Then agronomic efficiency, I think you know how to calculate it. Yield in treatment minus yield in control divided by rate of application of fertilizer. So here yield in, it cannot be worked out for 0. It can be worked out for 50. 4400 minus 3000 divided by rate of fertilizer. So 50 kg. You get 28 kg. Then 4700 minus 3000 divided by 100. Here you have to divide by 100. 4900 minus 4700 divided by 150. You get 12. Then 5000 minus 3000 divided by 200 and you get 10. So it is also getting decreased. And the unit is kg grain increase per kg nitrogen. Only difference is that here you have subtracted the control yield from the treatment yield and then divided it by the level of fertilizer. In the first case, you didn't do it. You did not deduct the control yield. You just straightway divided the output by input. But here control values were deducted. Now you see it can be represented because here as I was telling you, even partial factor productivity, we can do cost-benefit analysis. The other way to find out the optimum dose is through response curve fitting, because we do not know whether it is 100 kg. Suppose 150 kg is optimum dose. At 150, you got maximum benefit, but it could be 145, it could be 152, it may be some value around it. So it is not that exactly at 150 you will get maximum return. You can get return at 145 or 140 kg nitrogen. For this, we need to go for to determine the optimum dose of fertilizer. And this optimum dose of fertilizer is determined by using regression equation. I will teach you that subject after finishing this. So these kind of equations can be developed and we can find out the optimum dose of the fertilizer. I will teach you later. So you see, here the partial factor productivity values are decreasing. If you increase the nitrogen levels, the PFP kg grain per kg grain decreases. Similarly, agronomic efficiency also decreased, if you remember. Total factor productivity, when all outputs and inputs are included in the productivity measure, it is called as total productivity. Outputs and inputs are defined in the total productivity measure as their economic values. Economic values means monetary value. TFP is calculated as weighted average of the monetary value of various outputs divided by a weighted average of all monetary values of all inputs, including labor, capital, fertilizer, etc. Just you can remember the concept of total factor productivity. That is enough for us. And you need not to go into the details of total factor productivity. This is all means we should know about total factor productivity. Now, dear students, I am giving you some practice that you should try at your own. And please practice. I will not check it for you. But what I do normally, I get it done by students in classes. But since you are far away, but I advise you to do these practical exercises yourself. I just give you one example. You know how to calculate these blank spaces. Sometimes in your future quizzes, you may get these blank spaces and you have to use your brain, and they are very easy exercise, simple exercise. So here variable factor is given 0, 1, 2, 3, 4, 5. This is input. This is your total product, output values. Average product you can work out, and marginal product, I already taught you how to work out. This row divided by this row will give you average product. And then here, in both cases, you directly put 0. In the first column, 0, 0, all 4 have to be 0. Many times the students do mistake, yahi gadbad ho jata. All 4 have to be 0. Then it is easy. So row number 2 can be divided by row number 1. You will get row number 3. And row number 4 simply by difference method. You can calculate 8 minus 0. Start with 8 minus 0, you will get value here. 20 minus 8, you will get value here. 28 minus 20, you will get value here. So again, 28 minus 28, you will get 25. Now you will get minus value because 25 is less than 28. Here you will get 0 value. Now you have solved it. You can get like this. You got 0. And here you got minus value. So this is how you got these values. Now I'm giving you some exercises. Please do these exercises yourself. I have already perhaps shared the PowerPoint. This PowerPoint is already shared. So you can do these exercises. Answers are also given. But before seeing answer, you use your brain. The message, 1 point message is that you please learn it. Okay, learn this exercise. Similarly, you can calculate this. You can answer is given. The next. All answers are given. This is a bit complicated, but try to solve it without seeing the answer. Okay, answers are there. Or brain use karo. Aap log bahut hoshyar ho. I hope you can do it quickly. And we were able to complete this lecture. And hopefully, I will continue the same lecture. And tomorrow we will have this law of diminishing return in detail. And tomorrow itself, in 2 lectures, 2 continuous lectures, we will be able to finish that. Are you enjoying this kind of lecture? Is it working for you?
Yes, sir.
Palash?
Yes, sir. Yes, sir.
Good. So I think no time is left. So we end it here. I wish you all the best and God bless you. Thank you.
Thank you,
Thank you,
sir.
sir.
Thank you, sir.